So students, just I want to tell you one thing from the derivation. You have seen h square is equal to a square plus b square, right? And also at some other place you have seen h square is equal to gamma g square omega square mu epsilon. You can see your notebook, and both are equal. So you equate h square, that means a square plus b square gamma g square and omega square mu epsilon. Gamma g square is equal to minus omega square mu epsilon a square plus b square. Did you remember? Without derivation I was solving one equation. There I took this as capital A as a kx square. I took capital B as a ky square. And did you remember? You got here capital A is equal to m pi by A and capital B is equal to n pi by B. You got. So I was telling you, for rectangular waveguide kx becomes m pi by A and ky becomes n pi by B. Again gamma g, this we have taken kc square. Kc square we have taken. So same derivation you get after doing so much calculations. You got same thing only. Actually, I did derivation for TE mode, na. Similar derivations are for TM mode also, but for TE mode, actually, Hz is the main component. You got cos term you got, and for TM mode, Ez is the main component. After doing similar derivation, sin you get. Okay. These derivations are no way important for competitive exam. So that's why now let us start the exam discussion. For examination, what formulas are required? So let us read them, and we will be solving some questions also, right? So once again, for examination purpose, I am putting the heading that TEMN mode. For wave traveling in z direction, by definition of TE mode, EZS 0, HZS not 0. So HZS is equal to H0Z. Actually H0 means initial value of magnetic field of which component? Z component. So H0Z cos of m pi by A into x, cos of n pi by B into y, e power minus gamma gz. If you want in time domain, student, multiply with e power j omega t. For example, like this, hz of z comma t for wave traveling in z direction is equal to real part of hzs e power j omega t, that is nothing but real part of hzs is this one, h0z cos of m pi by A into x. So cos of n pi by B into y e power. Students, for f greater than fc, gamma g is j beta g. So j beta g into z e power j omega t. Because now we have seen whenever f is greater than fc, then only wave propagation is possible. Otherwise, wave propagation is not possible. Okay, for f greater than fc, gamma g is j beta g. Now that is equal to h0z cos of m pi by A into x, cos of n pi by B into y, and in this j is common, e power j omega t minus beta gz. So you pull real, then cos of omega t minus of beta g z. Why I told you this equation is, in examination sometimes they give these equations. If they give these equations, you need not to remember, they themselves give these equations in exam. So in exam sometimes they give in exponential form. In place of gamma g, they will give j beta g. Sometimes they put beta only, but that beta is to be understood at beta g only. Sometimes they give like this, cos omega t minus beta g z form. You should not confuse that we have not studied this type of equation like that. You should not confuse. If they have given like this, means it is in time domain. If they given like this, means it is in phasor domain, students. Just like that I told you. So this is equation number 1. Okay, and I told you that if f greater than fc, that implies gamma g is equal to, you have seen, j omega root mu epsilon root of 1 minus fc by f whole square was there, and we will be writing all those things now. Gamma g is equal to, this is called j beta g, because alpha g was 0. Already in uniform plane waves also I told you, if gamma is purely imaginary, then automatically alpha 0, there exists a traveling wave. I told you, no issue, कोई बात नहीं है. So बच्चे लोग ऐसा है, एग्जाम में अगर क्वेश्चंस है ऐसे इक्वेशन देके कौन सा मोड है रिकॉग्नाइज करो करके पूछता है, उसमें काजा ओमेगा टी माइनस बेटा जेड है, परेशान नहीं होना है, ये टाइम डोमेन में दिया हुआ है. ऐसा इक्वेशन देने में वो फेजर डोमेन में रहता है. ठीक है. सो अगर एग्जामिनेशन में ऐसे इक्वेशन देके मोड पहचानने के लिए बता देता है, आप लोग हेजेड देने के बाद जरूर, वो कोई डाउट नहीं है, टी मोड करके होता है वो. बट लेकिन बाकी ई एक्स, ई वाई, एच एक्स, एच वाई वो कंपोनेंट्स देने में वो टी भी हो सकता है, टी एम भी हो सकता है. वो सब चीज पढ़ते पढ़ते जाओ, वो डिस्कस करते जाएंगे. लेट अस continue the discussion. So Hz is over, students. Now electric field x component in phasor domain is initial value of electric field, not means initial value, electric field x component. Then you get cos m pi by a into x sin n pi by b into y e power minus of j beta g into z. Now electric field y component is equal to initial value of electric field for y component, then sin m pi by a into x, then cos n pi by b into y e power minus of j beta g into z. Magnetic field x component is equal to initial value h naught of x component, then electric field y component generates magnetic field x component. That is why these terms will be same. So sin m pi by a x cos n pi by b y e power j beta g z, and exs generates hys. That is why here cos sign comes, here also same thing comes. So h0 y cos of m pi by a x and sin of n pi by b into y e power minus j beta gz. So these equations no need to remember, actually they don't ask in examination. If they want to ask modes, they themselves give these equations. वो खुद equations दे के पूछता है. Anyway, if you want to remember, it is not a big task at all, very simple. For T mode, Hz is cos, then this is cos sin, you remember, and automatically no need to remember others. If it is this is cos sin, only you remember for this Ex, that is cos, this cos sin you remember, no need to remember others, because Eys will be opposite of this. Cos sin only you remember. If you remember all, then you will be confused nicely. Kisko cos, kisko sin, like that. Remember that is cos, and first one is cos sin, x component of electric field. That is more than enough. because this is opposite of that, and x component generates magnetic field y component. Then here cos sign same, and this generates this one. I used to teach them based on boundary conditions. Any one method is more than enough. Now I did not touch that method at all. That method is different method. Anyway, now start the discussion for examination. Actually here, what is m here? M is 0, 1, 2, 3, dash, dash, dash. It is basically integer. It is basically integer. This m represents number of half wave lengths, number of half wavelengths of E comma H fields, E comma H fields in x direction, in x direction, because m is beside x. Similarly, n is also integer, 0, 1, 2, 3, dash, dash, dash. So this is integer, and here n physical meaning is this is number of half wave lengths of electric and magnetic field, because this n is in the cosine terms of electric and magnetic fields, E and H fields in y direction. In y direction. If you want to see that, if you want to observe that, you can observe here. I am making to observe. Anyway, this equation that this is 1, this equation number 2, this is number 3, this is number 4, this is number 5. In this way, the way you wrote this equation जैसे लिखा है, सबको आप लोग टाइम डोमेन में लिख सकता है. Then cos omega t minus beta gz आता रहता है. Right, students? For example, I will do like this. Observation I am writing here, students. Observation, just to observe one thing. That's it. For example, I will take a cos beta z or otherwise sin beta z. I will take maybe cos beta z or sin beta z. I will take. For example, cos beta z is equal to cos of beta is 2 pi by lambda into z. So when z is equal to 0, here, okay, beta z is distance phase. Beta z is distance phase. Okay. At z is equal to 0, distance phase is equal to beta into 0. This is distance phase is equal to 0 radian. At z is equal to lambda by 2 distance, so distance phase becomes beta into z. Z is lambda by 2, so beta into z implies beta is 2 pi by lambda, so z is equal to lambda by 2 here. So ultimately this cancel, you got pi radian. So dear students, at z is equal to 0 distance, distance phase is 0, and at z is equal to half wavelength distance phase beta z becomes pi radian. From this conclusion you got for each lambda by 2 distance, that means half wavelength distance, there is a change of pi radians. That means for each lambda by 2 distance, that means for the meaning of this is for half wavelength, that means for lambda by 2 distance means for half wavelength. For each lambda by 2 distance, the phase difference is equal to pi minus 0 is equal to pi. Okay, this one. Now let us see this one. Let us see that x is meter, anywhere you take, no problem. X is meter, A is also meter. Meter gone. Then m into pi is phase, because inside cos, sin, tan, phase should be there. So m into phi is the phase. Meter gone, m into phi is the phase. So in maybe cos of m pi by x sin any term in the cos m pi by a x term distance cancel, m into pi is phase term. Now m0, that implies phase is equal to 0 into pi is equal to 0. M is equal to 1, that implies phase is equal to 1 into pi is equal to pi. M is equal to 2, that means phase is equal to 2 into pi is equal to 2 pi. Like that going on, m is equal to 3. Now phase is equal to 3 into pi, students. So that is 3 pi dash dash. If you are increasing integer, for each increase of integer, here phase also changing. Now the difference is equal to pi minus 0 is equal to pi. Now the difference from this one to this one is a phase difference is equal to 2 pi minus pi is equal to once again pi. Similarly, these two difference for this one and this one, for these two difference once again 3 pi minus 2 pi is pi only. It keep going like this. So conclusion, here each increase of integer, the phase difference is pi is changing. Now that pi is equal to the half wavelength change in the distance. Half wavelength change. That means integer 1, for example integer 2 you got, student. For example integer 2. For integer 2, I will do one thing. Difference is equal to 3 pi minus pi, that is equal to 3 pi minus 2 pi. 3 pi minus 2 pi is equal to pi. So m value is how much? 3. That means 3 number of half wavelengths. You see here 1, 2, 3. There is a 3 number of half wavelengths here, because pi radian means in terms of distance, that is half wavelength. So here m is equal to 3 you got. So 3 half wavelengths. You can see here 1, 2, 3. 3 number of half wavelengths changed. That we will see in the while drawing the diagram of electric field configuration also I will show you. So dear students, in this way m is integer, physical meaning is number of half wavelengths of electric and magnetic fields in x direction, because m is beside x. Similarly, n is integer, physical meaning is number of half wavelengths of electric and magnetic field in y direction, because n is in the beside y. That is why. So this discussion is simply explanation, and no need to read this one, simply observation, and just put that in the box. एक बार observe किया वो बहुत है, इतना बहुत है. Actually I did not put these equations also in the box. ये डब्बा में नहीं रखा, देखा आप लोग, ऑब्जर्व किया, डब्बा में नहीं रखा. इसका मतलब बुरी तरह रटने की जरूरत नहीं है. मैं बोल दिया अगर याद रखना है तो खास याद रखो, फिर इसको खास साइन याद रखो, फिर बाकी याद मत रखो बस, क्योंकि इसको उल्टा है. फिर ये इक्वेशन ऐसा है, फिर ये इक्वेशन ऐसा है, हो गया बस, राइट। सिमिलरली टीएम मोड के लिए वो EZS कंपोनेंट मेन है, वो वाला साइन साइन है मेन कंपोनेंट, बट बाकी ये कंपोनेंट सेम आएगा, कोई बात नहीं, राइट। नाउ dear students, let us start writing the exam equations which are required for exam. हम लोग डेरिवेशन किए थे एफ सी इज इक्वल टू, आई एम राइटिंग दिस इक्वेशन v डिवाइडेड बाय, तीन इक्वेशंस लिखा था मैंने, तीन में v बाय 2 रूट ऑफ m by, otherwise v by 2 pi I will write, so m pi by a square then n pi by b square. Otherwise you can write this like this, v by 2 pi gone, so m by a square plus n by b square. Already you kept this in the box, so dabba mein the ho, and this is called for mn, so it is called FCMN mode. So this is the first equation which you have to remember, because this is very important equation, right? 1 over, where v is equal to 1 by root mu epsilon, that is equal to c by root mu or epsilon r. Did you remember? This discussion is going on for f greater than fc only, because if f less than or equal to fc, there is no wave propagation, there are no equations, there is no discussion. So for f greater than fc, that gamma g is equal to j omega root mu epsilon root of 1 minus fc by f whole square, and this is nothing but alpha g plus j beta g, and I was writing this like this, j into beta g, because alpha g 0. Now from this equation, beta g is equal to omega root mu epsilon root of 1 minus fc by f whole square, and if you put mn fc mn, here also beta g you get for mn mode. This is very important. mn you should not forget, because they ask calculate guide phase shift constant for TE21 mode, na? Then you have to find FCMN for m is equal to 2, n is equal to 1, you have to substitute m is equal to 2, n is equal to 1, you have to substitute. Then mode to mode, this FC changes, then beta G also changes. You must carefully see for which mode that calculation is asking in examination. कौन सा मोड के लिए वो कैलकुलेशन पूछ रहा है, वो भी ध्यान से देखते रहना है. ये इसका नाम क्या है? इसका नाम इधर, वेयर एफ सी ऑलरेडी आई रोट, पहले लिखा था और एक बार लिख रहा हूं, कट ऑफ फ्रीक्वेंसी फॉर MN mode. Next, beta G, MN is nothing but G means guide, beta means phase shift constant or otherwise wave number. So phase shift constant, or otherwise you can write guide wave number also. So guide phase shift constant for MN mode. Okay, sequence student, to solve the questions, first you have to find FCMN, because beta G needs FCMN. Okay, then once if beta G is over, then we can go for phase velocity. You see here students, phase velocity is equal to V is equal to omega by beta, omega by omega root mu epsilon, that is equal to 1 by root mu epsilon, that is equal to c by root mu r epsilon r. This discussion is for uniform plane wave. For uniform plane wave, or otherwise uniform plane wave is nothing but unbounded medium. Unbounded medium for uniform plane wave. This one for uniform plane wave. ब्रैकेट में रखा है ये, ब्रैकेट में रख दिया. Now velocity, phase velocity is equal to omega by beta for uniform plane wave, that is unbounded medium. But for a waveguide, you put beta g, you put beta vg, but omega is not going to change. If wave enters into the waveguide, then also frequency same. Wave comes out of the waveguide, then also frequency same. But when wave enters into the waveguide, then wavelength changes, velocity changes, wavelength and velocity changes in similar way, but frequency is not going to change. Okay, so this is Vg means guide phase velocity I am taking. So this is the definition of this one. It is the definition, guide phase velocity. Because I have taken a uniform plane wave definition, there beta is omega root mu epsilon. But if I put beta g here, then I get guide phase velocity. So this Vp here, constant phase velocity in unbounded medium or otherwise uniform plane wave, students. Okay. Now this is equal to, let us do the derivation, and omega divided by beta g is equal to, beta g is this one here, omega root mu epsilon and root of 1 minus of fc mn divided by f whole square, right? Omega cancel, and 1 by root mu epsilon is this one phase velocity. So that is v I am writing here, divided by root of 1 minus fc mn divided by f whole square. Now from this, this is the definition actually. Now guide phase velocity is equal to v divided by fc mn divided by f whole square. This is the guide phase velocity for mn mode, student, this one mn mode. Now here one by one I will write. Here I am telling you one point. If f greater than fc, then this factor called 1 minus fc by f whole square is always less than 1, student, this factor. Denominator less than 1 means numerator it comes more than 1. So Vg mn is always greater than V. This discussion is also important. What I am telling you is that if f greater than fc, then fc by f is less than 1, then fc by f is less than 1 whole square, 1 minus less than 1, so it is less than 1 inside, root of less than 1 is less than 1. But now here denominator less than 1 is there. If it comes to for example, you take this as a half, less than 1 means half, in numerator it comes 2, like that. So this is conclusion is guide phase velocity is more than the unbounded medium phase velocity. I will write the, now important thing is where v is equal to 1 by here now v is equal to 1 by root mu epsilon, root mu epsilon, that is equal to c by root mu r epsilon r. This is phase velocity of unbounded medium. That means uniform plane wave. If you want to see, I will show you that this thing. For example, fc mn is equal to you say v by 2 root of m by a whole square, n by b whole square. Unbounded medium means no waveguide walls. That means you take a infinity, b infinity, Then where conductor walls are at infinity distance, infinity width, infinity height, you can't see the conductor walls, that means there are no conductor walls. Then A infinity, B infinity, Fc, you get 0. So implies Fc 0. You substitute Fc 0 here, 1 minus 0, 1 root of 1 is 1, and you get V, that V is 1 by root 1 by root mu epsilon. So that is unbounded medium. Unbounded means there are no conductor walls at all. That's why phase velocity of unbounded medium or otherwise uniform plane wave. So dear students, in the waveguide na, you put A infinity, B infinity, you get the uniform plane wave. In the waveguide, you put A finite and B infinity, then automatically you get a parallel plane waveguide. It is very simple. You have to study in simple way. Unnecessary, some faculty, they start doing derivations for parallel plane waveguide also. Simply you put A not 0, B infinity, you get equations for parallel plane waveguide. Remembering is also easy. Actually, concept is also same, but they unnecessarily solve, they trouble the students. I have told you, before this I do derivation. That is only troublesome only. कोई बात नहीं है. So that too, parallel plane waveguide is not doesn't exist practically. So no need to study that. Anyway, at the ending I will write equation for that also, so that rarely you will get question. You will not get at all in a GATE exam. Rarely if you get question, you can easily solve from that formula. I will tell you later on. Don't worry. Yeah, what I was telling you, two statements I told. If A tends to infinity, B tends to infinity, then in the rectangular waveguide A tends to infinity, B tends to infinity, you get uniform plane wave. If A not 0, B tends to infinity, then that becomes parallel plane waveguide. I will tell you later on. So if A not 0, B not 0, that is rectangular waveguide. If A is equal to B, that is a square waveguide, square shape, like that. Anyway, students, now what is VGMN? In some books, VG is taken as a group velocity. I am not taking like that. I am taking a guide phase velocity. Small g means guide. आप लोग परेशान नहीं होना, दिमाग लगाना. In any textbook, if this formula is there, we divide by this factor is in denominator. Whatever might be the name of this one, that is guide phase velocity, my dear students. उसका नाम कुछ भी होने दो, V small g, V capital G, V कुछ भी होने दो इधर नाम. If V divided by this factor is there, root of 1 minus Fc by F whole square factor is there, denominator factor is there, then whatever might be the name, different countries, different textbooks, different symbols they use, but don't bother, that is guide phase velocity. You should not disturb that easily. उतना आसान से symbol को लेके परेशान नहीं होना, ठीक है? So 1 by root mu epsilon divided by this factor is there, then symbol may be any symbol, that is called guide phase velocity. That means inside a waveguide phase velocity. So here Vp in uniform plane wave, we were saying constant phase velocity, like that. I did a derivation, you go and see in uniform plane wave. Anyway, here Vg Mn is a guide phase velocity. So what is that? Guide phase velocity for Mn mode. VGMN. Guide, that means waveguide, student. Phase means constant phase, that is phase velocity for Mn mode. Okay. Next, lambda formula. In the uniform plane wave, lambda is equal to 2 pi by beta. That is equal to 2 pi by beta is omega root mu epsilon. 2 pi divided by 2 pi f root mu naught epsilon naught and root mu r epsilon r. Okay. Root mu r epsilon r. 2 pi cancel. This is C by f. That means C by f divided by root mu r epsilon r. That is called lambda naught. Lambda naught by root mu r epsilon r. Now lambda is wavelength of uniform plane wave, that is unbounded medium. That means not in the waveguide. Now lambda is equal to 2 pi by beta. In place of beta, if I take g, then lambda g I have to take. Lambda g. Lambda g means a guide wavelength. That means whenever wave travels inside the waveguide, how much wavelength is there for that wave? That is called guide wavelength. 2 pi beta g is omega root mu epsilon root of 1 minus fc by f whole square. This is omega is 2 pi f, 2 pi gone, and this is written as lambda. See here na, this one 2 pi divided by, here you can see na, 2 pi divided by omega root mu epsilon is written as lambda. Okay, top side. That lambda is nothing but lambda naught by root mu or epsilon r. So directly I am writing 2 pi by omega root mu epsilon as lambda. So that lambda divided by root of 1 minus fc by f whole square. Actually, one thing I want to tell you, wherever denominator beta g is there, na, that factor will be extra in the denominator. If beta g is the numerator, then that factor will come in the numerator. That factor is always less than 1 for f greater than fc. You have to remember that. Already I wrote there. So here lambda g is equal to lambda divided by lambda g is equal to lambda divided by root of 1 minus fc mn divided by f whole square, and this lambda g is for mn mode. Okay, where lambda is equal to, I will write like this, lambda naught by root mu or epsilon r, where lambda naught is equal to c by f, light velocity divided by root mu or epsilon r, light velocity by f into this one. So here lambda is wavelength in the uniform plane wave, or otherwise wavelength in unbounded medium. Unbounded medium. This also you have to remember, because formulas remembering means this formula you remember, inside this what is lambda you have to remember. वो लोग एफ देता है, then mu or epsilon देता है. For example, air field waveguide means this one you have to take, then f is given, then c by f you take, you get lambda. Lambda g mn means g means guide, waveguide, that is lambda means wavelength, guide wavelength for mn mode. Okay, that one. Once again I am telling you, this is important point. If f greater than fc, then only wave travels in the waveguide. Then this factor fc by f is less than 1, fc by f is less than 1, then 1 minus less than 1 whole square is much less than 1, 1 minus less than 1 is less than 1, root of that is less than 1. This factor is always less than 1. You remember, for wave propagation, that means f greater than fc. Then if that factor is in the denominator, then automatically if it comes to numerator, then this side this value will be more than 1, then this quantity will be more than this one. So if this factor is in the numerator, then this side quantity will be less than this quantity. So you have to remember a few facts actually. ये सब facts है, याद रखना. इसको भी बॉक्स में रखना आप लोग. इसका नाम क्या है, ये जो लिखा हुआ है. So in this formula, I told you, no, in the velocity formula, beta comes in denominator, na. In the waveguide, this factor will be in denominator for the velocity. So till now, how many formulas you have remembered? Only one more formula is remaining. FC formula, beta formula, then velocity formula, wavelength formula, last formula is impedance formula. Only 5 formulas are required, and it is very easy because for TM modes also same formulas. It is bonus for you. So in TE mode and TM mode, FCMN formula, beta G formula, guide phase velocity formula, wavelength formula, and they are all same except the eta formula. Eta G for TE mode is different, eta G for TM mode is different. I will tell you, if this factor comes beside velocity, that is called group velocity. The symbol might be anything. Later on we will talk of that one. बाद में बात करेंगे उसको. So here one thing is there. I will write this later on, student. इसको बाद में लिखूंगा. ये भी एक objective question है. That is also one of the objective question. So final equation is impedance equation. Impedance equation. I was doing derivation, impedance equation for TE mode I got, you could remember j omega mu divided by gamma g, and j omega mu divided by gamma g is j beta g, j cancel, omega mu, beta g is omega root mu epsilon 1 minus fc by f. Simply they no need to do derivation, because eta you are writing na, eta by this beta g in denominator means eta by that factor will come in denominator. So eta by root of 1 minus fc by f whole square will be the answer. So this omega gone, and then here one root mu cancel. So ultimately you get this one root mu by epsilon divided by root of 1 minus fc by f whole square, that is written as eta by root of 1 minus fc by f whole square, students. Right? So ultimately you have to remember this one. Eta G. Eta means impedance. G means guide impedance. Suffix T means for TE mode. That is equal to eta divided by root of 1 minus FCMN divided by F. So here this is for TEMN mode. So eta G, guide impedance for TEMN mode, then MN you have to put. So this eta is equal to root mu by epsilon. This is impedance or otherwise intrinsic impedance of unbounded medium. Unbounded medium. So this one, students, eta G, that means G means guide, eta means impedance, guide impedance, TEMN means for TEMN mode, because for TM mode this factor will be beside this, उतना ही difference है. So if I talk of TM mode equations na, so in TM-MN mode actually what will happen, dear students, there EZS will be proportional to sin m pi by a and sin n pi by b. I will be writing, just you are listening, don't write everything, student. Just you are listening, before removing them, just you are listening. सुन रहा है आप लोग. TM-MN mode, EZ equation will be there, that is sin, but in TE mode, HZ equation is there, that is cos. And other equations like EXS and EYS, HXS, HYS, FCMN and beta GMN and phase velocity for MN mode and guide wavelength for MN mode, all the equations are same for both the modes, and only eta G Tm Mn mode is equal to eta root of 1 minus Fc by F whole square. This factor will be uh, beside this eta. There this factor is in the denominator, and there this factor is in numerator. Only that much difference is there, student. Otherwise Tm mode equations are same. Actually, for examination, what is required, that is important now. I told you for examination FCMN formula is required. If you want, you can remember for T mode Hz is there. Hz is cos, then electric field X component will be cos sine. That much is more than enough. And then FCMN, beta GMN, and guide phase velocity for MN mode, and then wavelength for MN mode, guide wavelength for MN mode, and guide impedance for TMN mode. You have to remember, and other than that, nothing else to remember. Okay, so this I am going to write later on, बाद में लिखूंगा इसको. Now here which TE modes are possible? Which TE modes are possible? That we have to discuss. So possible TEMN modes, that is the discussion. Which modes are possible? Right, first one. For this I have to make you recall the equations. I will write the equations, very simple. So for this mode EZS, this ink is little less. So already these equations are there. You don't write these equations. I am writing here. Already they are there in your notebook. This one HZS is equal to H0Z cos m pi by ax cos n pi by by e power minus of j beta g z, and Ex is equal to E0x. I told you to remember this, only cos comes here, m pi by ax, then comes sine, so n pi by by e power minus j beta g z. Eys is opposite of this one, E0y, initial value of electric field y component, then sine m pi by ax cos n pi by by e power minus j beta gz. Hxs is equal to H0x, then electric field y component generates this one, so sine m pi by ax cos n pi by by e power minus j beta gz. Then magnetic field y component H0y cos of m pi by ax sine n pi by by e power minus of j beta gz. Now to carry power in z direction, either these two pairs jodi Ex and Hy jodi, or otherwise Ey and Hx jodi can carry the power in z direction, right? Now let us discuss one by one. Possible TEMN modes. First one is TE00. That means for this M0, N0, that implies HZS is you got HZS is equal to H0Z into e power minus j beta g into z. So here this x0, y0, this m0, n0, cos 01, cos 01, 1 is there. But here there is no variation. Mother component is there. There is no variation. That means automatically power cannot flow. Let us see here. It will be confirmed. So EXS, here you can see in this EXS n0 you put sin 0 0, then if electric field x component 0, automatically this also becomes 0, so that is also 0. Similarly n0 you put here, m0 you put here, then here m0 0, all are 0 student. EXS 0, then EYS 0, then HXS also 0, HYS 0. Then if this component is 0, then this one is 0. If this component is 0, then this one also 0. The meaning of this arrow mark is this generates this one, this generates this one, this generates this one, this generates this one. This is 0, this is 0, this is 0, this is 0. There are no electric field components which carry the power in z direction. Only this pair can carry power in z direction. This pair can carry power in z direction. Both pairs not there now. एक दो जोड़ी थे, वो दोनों में कोई एक जोड़ी या दोनों जोड़ी मिला के पावर लेके जाता है. ये जोड़ी भी लेके जाता है, वो एक ऑप्शन है. ये जोड़ी भी पावर को लेके जाता है, वो सेकंड ऑप्शन है. दोनों जोड़ी मिलके वो थोड़ा ये थोड़ा पावर को लेके जाता है, वो भी एक ऑप्शन है. बट इसमें कोई ऑप्शन नहीं है. पावर कैनॉट बी कैरीड इन T00 mode. No power flow is there because field equations are 0. If there is no power flow, then you say mode does not exist. Mode exist means there are field equations which carry the power in z direction. MODE mode. For example, I am here. After the class, I have to go to home. In which mode I go? I may go in the walking mode. I may go by bike. I may go by car. I may go by train. There are different modes. Similarly, power is to be carried in the waveguide from input side to output side. Which mode? The mode may be EYHX component, that is one mode. EXHY component, that is another mode. This also carry little bit power, that also carry little bit, so that is another mode. So different modes. Again, by changing mn values, you have different modes. So mode means the way you carry the power. हिंदी में बताना है तो आपको कौन सा तरीका में पावर को लेके जा रहा है उसको मोड बोल देता है. मोड, right? Mode doesn't exist means there is no possibility of power transmission from input side to output side in the waveguide. So here if you want discussion, that E cross H is equal to 0 here. That means there is no power flow here. So there is no power flow, E cross H 0. There is no power flow, so T00 mode does not exist. And without seeing these things directly, you can tell here, to have a power flow, this should be present. There should be one of the variable term here, and maybe this pair or this pair should be there, or both pair can be there. Then only power flow is there. Next, T10 mode. For this, m is equal to 1 and n is equal to 0. In this, you substitute m is equal to 1 and n is equal to 0. Then HZS becomes H0Z cos of pi by a into x, this n0, this is 1, e power minus j beta gz. In this there is a variation, so definitely some other terms will be there, they carry the power. Now let us see here, n0 means this is 0, this is also 0. So here electric field x component is 0, then that generates magnetic field y component, that becomes 0. Then here electric field y component is equal to E0y into n is equal to 0 means cos 0 is 1, m is equal to 1 sin pi by a into x e power minus of j beta g into z. So here hys was 0, right? Now this component of exs component, this one definitely makes hxs component present. So hxs is once again h0x m is equal to 1, you have to substitute. So sin pi by a x into this is n0, you have substituted, that is 1, and e power minus j beta z. Actually this term no need to write, student, because power is carried by modulus of Ey. If you take modulus of Ey, for example, power carried is Ea0 whole square eta half, like this average Poynting vector was there. For electric field, take mod. If you take mod of this is magnitude, mod of this becomes this is modulus of e power j minus j theta, that is 1 actually. So anyway, no need to write that one. Okay, written means okay. Now here E cross H is possible. E cross H, this term 0, but here electric field y component, magnetic field x component, they carry the power. So that's why power flow exists here. So here Poynting vector so is equal to E bar cross H bar. That means electric field component is there, y component, and magnetic field x component is there. So this is not equal to 0. This one is not equal to 0 because components are there. So not equal to 0. That implies power flow is possible. So mode exist. That means TE10 mode exist. Mode means the way you carry the power. If power flow is possible means mode exists. Otherwise mode doesn't exist. Right. Okay. Now I will do one thing. Here, if this is the magnitude of the electric field y component, at x is equal to 0, Eys is equal to E0y into sin x0, so you got 0. Next, at x is equal to a by 2, Eys, what am I doing? Electric field y component magnitude is a function of x. So keep changing x, then electric field varies sinusoidally. So Eys, then E0y sin pi by a, x value is what, student, here? A by 2. That means E0y, a cancel, sin pi by 2 is 1, this is E0y. That is the highest value because a sin, then a is the highest value, that is the highest value. So at x is equal to a, then Eys is equal to E0y sin pi by a into a cancel. So sin pi 0 you got. Now I am drawing the configuration. Field configuration means shape. Configuration means shape. So field shape. So this is x-axis and you take a little bit straight line I will draw. So like this. This is x-axis, this is y-axis, but I am taking EYS, modulus of EYS I am taking, students. Modulus of EYS I am taking. Magnitude of electric field Y component. Now this is front end of the waveguide, front end. So this is x is equal to 0. So this is x is equal to a by 2, and this is x is equal to a, right? Now x is equal to 0, electric field is 0. X is equal to a by 2, that means here electric field is E0y, that is the highest value. So I am drawing like this. That means from 0 to a by 2, x increases, no? This sign value also increases like this. And again it decreases, keep decreasing. Then it becomes 0. So sinusoidally it goes like this. Can you tell me? Sine signal is this one, student. This is one period. If you take this distance, then this is lambda by 2. This is lambda. Then you take modulus of this. Modulus becomes. If you take mod, this also goes top side negative value. Like this comes. So this is lambda by 2. This is lambda. So this is half wavelength. This is another half wavelength. This has two half wavelengths, but it is only having one half wavelength. That is why one half wavelength is there. That is why one mode. M is equal to 1 means number of half wavelengths in x direction. I told you na. M indicates number of half wavelengths of field components in x direction. Here TE10 means M is equal to 1. M is equal to 1 means one half wavelength of the field in x direction. So one half wavelength of the field, this is a field y component here, electric field y component in x direction. That is the meaning of that. So in the textbooks, some lazy people, they draw this like this. Simply they draw this like this. X and electric field y component, simply they show the arrow mark like this. One half wavelength, one arrow mark, other half wavelength, downside arrow mark they will show in some textbooks. Some textbooks, for one half wavelength, two arrow marks like this they show. Another half wavelength, two arrow mark down they will show. So here this is shown like this in some textbooks, EYS like this they show. That means upward means one half wavelength over, downward means one more half wavelength it will come. That is the meaning of that. So dear friends, here actually this T10 mode is the dominant mode. Power is carried through this mode only. So anyway, here one thing you remember, these electric field lines perpendicular to x, then this variation should be written for m. You remember, this variation should be written for m. These electric field lines are perpendicular to the x. So or otherwise you can say like this also, half wavelengths are coming in x direction, then you have to, if two half wavelengths come, then m is equal to 2. In x direction, one half wavelength come, then m is equal to 1. You have to put like that in examination if they give for recognition. While solving the question, I will tell you little more observation there. So don't worry about that. Next, okay, one point. This point I will tell you in the powers. I will tell you. Don't worry. Now you will not be disturbed much. Anyway, for this mode, if you want magnetic field component, student, this one you see here. I am doing like this. Arrow mark. One arrow mark means something I will discuss. one more arrow mark means इधर और कुछ दूसरा discussion चलता है. For one arrow mark, one discussion over. Another arrow mark, I will do one more discussion. Now, can you tell me what is this? Modulus of HZS is equal to mod you take this is 1. So, H0Z, then cos of pi by AX. That implies, no, I will not put arrow mark. From this, HZS divided by H0Z is equal to cos of pi by AX. Let us say this equation number, till now no equation number 1. Now here Hxs also is there. So modulus of Hxs is equal to this one. H0 x, student, H0, that means H naught means initial value of magnetic field of x component. That is the meaning. It is written like that. Then sine pi by Ax, modulus of this is 1 once again. Then from this Hxs divided by H0x is equal to sine pi by Ax. This is equation number 2. Now equation 1 square plus 2 square implies this one Hx s divided by H0x whole square plus Hzs divided by H0z whole square is equal to 1. So this is ellipse equation. X by a whole square plus y by b whole square is equal to 1 is ellipse equation on xy plane. And Hxs by H0x plus Hzs by H0 is whole square. That means it is ellipse in x comma z plane. X comma z plane, student. This is waveguide. This is A in x direction. This is B in y direction. And this one is z direction. That means x means this one. This one. Z means this one. That means that is this one, this plane. On this plane, magnetic field shape will be elliptic, ellipses, simply circles, little bit bend. Actually, this is circle, and this is circle, and ellipse means circle only, but little bit as a hit karo, why ellipse. So that becomes ellipse like this, or maybe like this. Right, students? So if you want, now I am showing this here. This is the, I told you, x by a whole square plus y by b whole square is equal to 1 is ellipse on xy plane. Then magnetic field x component, z component is there. This is ellipse on xz plane. This is x axis and this is z axis. So if I draw like this, this is x and this is z actually. Like this I kept. So now on this, simply you have to draw the, what do you say, like this ellipses. You know why I am drawing like this, student? Because magnetic field lines are closed lines. I have to draw like this actually. Closed line means I have to draw like this, like this, like this. But in the book, no, these are called solid line. These solid lines are used for electric field actually, for electric field. This solid line, continuous line is used for electric field actually. But this dashed line is used for magnetic field. So actually it is a closed line only. Magnetic field lines are closed lines. So like this they will show, dashed lines. They are like, what do you say, ellipses and closed lines. So ultimately they will be going like this, and here like this. So here they will be coming like this. Here, no, like this they will be going. So arrow marks like this, like this. Anyway, are there more? No issue. Like this it is going. Okay. That's why if you give arrow mark here, that is more clear. If you give like this means it will go like this, na. So no need to give the arrow mark here, so that you will have more clarity. okay, like this. So here arrow marks are given, dear students, upward. 3 field lines, 3 arrow marks I have given. Okay, right. Now, third one, TE01 mode. That means m is equal to 0, n is equal to 1 student. In first phase you write then HZS becomes H0Z. This is the first term is 1 and cos of n pi by b into y. So pi by b into y e power minus j beta gz. And here electric field x component is equal to E0x. You can see here wherever 1 is there, their sign term comes. So ultimately sin n pi by b into y, and you will have e power minus j beta z. Exs generates what do you say, magnetic field y component, that is H0y. So you can see here now equations if you want, these equations only. T01 means you put 0, then it becomes 1, cos 0 is 1, here is 1. So sin pi by b into y, that's what I was writing. And then automatically HYS, this also sin pi by b into y. From this only I was writing. Okay. So H0y, sin pi by b y e power minus j beta z. I told you this term will not appear in power flow, that is mod is taken. Then electric field y component is 0, then electric field y component generates magnetic field x component, that is also 0. Anyway, here also Poynting vector is equal to E of t cross h of t, that is not 0, students. So that is why power flow present, power flow is possible. So mode exist. Here also I wrote same thing. Poynting vector is not 0, power flow possible. In this way, all TEMN modes possible except TE00 mode. This mode is not possible, all other modes are possible, student. Okay, that is the conclusion. What is the heading? What are the possible TEMN modes? Then answer all TEMN modes possible except T00. So here all TEMN modes are possible except T00. Right? Now let us talk of TMMN modes. Right? In the TMMN modes, I can put these equations, no? So I will use this place. I will start from there so that I will use that place. TMMN modes, transverse magnetic. For the wave traveling in z direction, by definition of TM modes, EZS not 0, comma HZS 0. Once again here M means same integer, number of half wavelengths, same story here also. M means 0, 1, 2, dash, 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 integer which represents number of half wave lengths of EH fields in x direction. Similarly, n is also an integer, and circular waveguide is also same thing, come integers only. Integer, then number of half wave lengths of EH fields in y direction. Okay. Now coming to the equations. Here comes main component is EZS, that becomes a sine, and others will be same. Similar. I will write here. For TMMN modes, EXS, EYS, HXS, HYS, because I don't want you to remember separately. That's why. Comma, FCMN, beta GMN, guide phase velocity for MN mode, guide wavelength for MN mode. For TMMN modes, EXS are same as TEMN modes. That means for TMMN modes, these equations are same as TMN mode, students. Here I told you one thing, my dear students. For example, in examination, if they ask you like this question, they have given Hz is equal to H0z cos of 3 pi by Ax cos of pi by by, then they will ask like this, cos of omega t minus beta g z, find the mode. They will ask like this, find the mode. Then you see here, wave is traveling in plus z direction. For wave traveling in plus z direction, Hz is given. That means that is TE mode decided. So TE mode, and here M is 3 and N is 1. TE31 mode is the answer. Okay. Next, second question. Given in examination, it is given EZS is equal to E0Z, or otherwise 3 something like that. They will give student 3 some value they give, and the sine what do you say, 1 pi by Ax, they don't give here anything, and sine 2 pi by b into y, then cos of or otherwise sine of omega t minus beta g into z is given in exam. So wave is traveling in z direction and z component is given, 100% should be TM mode only. There is no option. And TM n is equal to m is equal to 1 and n is equal to 2. This is the mode. So dash mode, Answer is this mode, dash mode. Answer is this mode, given this one, given in exam. These two things are very clear for you, because I told you the main component in TE mode is HZ, but the main component in TM mode is EZ. EZ is main component. Yeah, that's why first this equation is written here. EZ is main component, right? Now the question is given like this: E XS is equal to some like this is given 10 EXS. So cos of 2 pi by AX, then sine of 3 pi by by, then maybe something is given like this in phasor domain. It is time domain, means S should be removed, student. Time domain में दे दिया ना वो. So here e power minus of j beta g z. Then what is this mode? You see, students, electric field x component equation is same for both the modes. So you cannot decide whether it is TE or TM. So first of all, from this n m pi by a, m is equal to 2, n is equal to 3 is given, right? Now that is why it may be TE mn mode, or otherwise it may be TM, it may be TM mn mode. That means it may be TE23 mode, or it may be TM23 mode. That means with this equation both modes exist. So answer is this is the one, TE23 or otherwise TM23 mode. So that is the meaning, student. So EXS. That means whenever EXS for wave traveling in Z direction, EXS for wave traveling in Z direction, EXS, EYS, HXS, HYS equations are given, then answer is any one of the mode. Okay, both modes are not any one of the mode, both modes exist. Now I will tell you one more variation by telling this one, and I will write one thing here, students. After telling the modes, I will tell. Anyway, for this eta g formula, I am writing here, students. Eta g formula. Eta g for this mode, for that j omega mu by gamma g you get, after doing derivation, gamma g by j omega epsilon you get. That means this is j beta g. This is derivation, after derivation you get for this. So for this mode, j omega epsilon, that means j omega root mu epsilon root of 1 minus fc by f whole square and divided by j omega epsilon, j omega cancel, and here root mu epsilon, this factor is beside this 1 minus fc by f whole square. This is eta into this one. So ultimately this is equal to eta into this factor is beside that eta, student. That is the important point here. So I am writing that here. I told you for TE mode and TM mode, only this equation for TE mode HZS is present, for TM mode EZS is present. For TE mode eta formula, this factor is in the denominator. For TM mode, this factor is in the numerator. That is only the difference. So I am putting in the box eta g for TM mn mode is equal to eta into root of 1 minus fc mn divided by f whole square. So that after writing this na, your life is very simple to remember the formulas. आपका आसान हो जाएगा. So this one is for TM mode, where eta is root mu by epsilon, that is 120 pi root mu r divided by epsilon r. Then here eta g TM eta g means guide, eta means intrinsic impedance or simply impedance, anyone you can call, guide intrinsic impedance for TMMN mode. Okay, right. After discussing this, possible TMMN modes, it is very simple, student. M0, N0, both of them 0. Sign is there. You put M0, this is gone. Mother component gone. Main component gone. N0 gone. Both 0 gone. That means when this term remains, M also should not be 0, N also should not be 0. Then only TM modes exist. That is why no need to do much exercise. Come here. Come to the definition. TM mode. EZS not 0. What happens if EZS 0? If EZS 0, then already HZS 0, then both 0. That is TEM mode. Already we have studied in single conductor structure, TEM mode doesn't exist. Right? So it is that simple discussing. So TM M0, comma TM 0N, comma TM 00 modes does not exist. That means power flow is not possible in these modes because the main component that is EZS becomes 0. So because the main component EZS becomes 0 and there is no power flow. And there is no power flow. So other than this, all modes possible. Okay. I will write the statements. All TMMN modes possible except TM00, TM-M0, TM0N. That is the statement, student. All TM modes, TMMN possible except M0, N0 or otherwise N0 or otherwise M0, any one of them 0. So those modes are not possible. These modes not possible. Now I will ask one more question based on the mode, student. Based on the modes. One more question I will ask. Okay. EXS is equal to, given in the examination, that is 10 sine 2 pi by b into y e power minus j beta z. Then find the mode of this one. What is this mode? Then answer. Electric field x component is given for wave traveling in z direction. So it may be TE mode or otherwise it may be TM mode also. So here there is no x variation. No x variation means M0 taken. You can see here M0 taken, EXS take M0, then cos 0 becomes 1. That means no x variation. Next, because x variation is not there here, students. Next here From this you can decide this is over here. X variation is not there. That means M0. Here n is equal to 2 taken, m pi by n pi by b, 2 taken. That means this mode is TEMN or otherwise TMMN, because TE mode as well as TM mode, for both modes electric field x component equation is same. That means this mode is TEM means 0, n means 2. It may be TM02 mode, any one of the mode. But what are you studying here? You are studying in TM modes either M0 or N0. This mode is not possible. That is what you are studying here. वही पढ़ रहे थे आप लोग. That means this mode doesn't exist. So final mode is TE02 mode. So mode is given mode is TE02 mode, student. So because this mode does not exist, this mode does not exist, TM what do you say, TM02 does not exist. That is why the final answer is this is the answer. So total I have solved 4 questions for modes. Na? In exam this question is given, then find mode. Answer is TE02. In exam this question is given, then find mode. It may be TE23 or TM23, both can present. Like this, total 4 questions on modes. Okay. Now after this we are going to discuss some other topic in this. So dear students, now let us talk of dominant mode. Right? Dominant mode. So actually you know that, for example, we have seen in the waveguides gain versus frequency. This is cutoff frequency Fc. If frequency is more than cutoff frequency, then only it transfers the signal. If frequency is less than Fc, then signal cannot be transferred. For example I am taking. After calculation, Fc is equal to 1 gigahertz I got. What is the meaning of this? If frequency is more than Fc, that means frequency is more than 1 gigahertz, then only we can transfer the signal. Otherwise, we cannot transfer the signal. That is the meaning. So, second example, Fc is equal to 10 gigahertz. That means F greater than Fc, then only we can transfer. So, if F greater than 10 gigahertz, then only we can transfer the signal. Among them, which one is better one? This is the better one, because in this we can send the frequencies from 1 gigahertz onwards. But here we can't send the signals from 1 gigahertz to 10 gigahertz. So that means it has higher cutoff frequency. So if any waveguide having 0 cutoff frequency means the meaning is it transfers signals from 0 hertz to 0 hertz onwards it can transfer. But to have 0 cutoff frequency, you have to take you have to take 2 pi root of m pi by a whole square, so n pi by b whole square. If you want to have 0 cutoff frequency, then a should be infinity and b should be infinity. So ultimately you get Fc 0, but a infinity, b infinity means you have a waveguide of infinite dimensions, so it is not possible to construct that type of waveguide. To get 0 frequency, cutoff frequency, a should be infinity, b should be infinity. That means there is no waveguide at all. So that is why that is not possible. Next point is waveguides they are in centimeter dimensions, few centimeter. If you, this is like waveguide, you take this 2 centimeter, this is 1 centimeter, then if you substitute the a in centimeter, b in centimeter, then Fc value you get in gigahertz. That is why always we talk in terms of gigahertz. So it is easy to handle the waveguides of size centimeter size. So for frequencies less than gigahertz, we have coaxial cables and transmission lines for transferring the signal. Okay, so conclusion is, after putting the heading dominant mode, I came to this discussion. Here we understood that if cutoff frequency is very less, that is good. We can send the frequencies above that. So if cutoff frequency is 0, that is the best. If cutoff frequency is 0, then we can send the frequencies from 0 Hz onwards. But that is not possible. For that you have to put A in infinity, B in infinity. So if A in centimeters, B in centimeter, we will see in the problems, we will get FC in gigahertz. So these frequencies are in gigahertz range. Finally, I told you there are two waveguides, waveguide 1 and waveguide 2, and this has cutoff frequency 1, this has cutoff frequency 10. So among them, better one is this one, so that you can send more frequencies in this. So that is why a dominant mode is defined like this. The demand is lowest cutoff frequency should be there. That means highest cutoff wavelength. For example, V is equal to lambda into F. V is equal to, if I take cutoff here, then cutoff frequency you have to take. So lambda C is equal to V by Fc. So if lowest cutoff frequency is there, that is called dominant mode. The cutoff frequency lowest means it is in denominator and wavelength is highest actually. That is the definition of the dominant mode. So dominant mode definition is the mode having lowest cutoff frequency or highest cutoff wavelength is called dominant mode. That is the definition. So dear students, dominant mode. Dominant mode means the mode having lowest cutoff frequency and highest cutoff wavelength. Dominant mode is defined as the mode having lowest cutoff frequency, that means Fc, or highest cutoff wavelength. Cutoff wavelength means lambda c. Okay, so that is the definition, that one. Now let us observe. So observation. Let A is equal to 2, B is equal to 1. That means we have taken A greater than B in waveguide. Now FCMN is equal to V by 2 root M by A whole square plus N by B whole square. Right? Now first one is actually FC 0 0. So if you substitute FC 0 0, then what you get is FC 0 0 is equal to M0 N0, you get 0 cutoff frequency. For this, what modes can be present? TE00 and TM00 modes can be possible. If they are there, then they can be possible. But we have studied that TE00 mode does not exist and TM00 mode does not exist. So that is meaningless discussion. Second one, I will write here. So FC00 cutoff frequency for 00 is 0, that happens for TE00 mode and TM00 mode, which does not exist. I am writing here. Now second one is FC10 mode. The FC10 means M is equal to 1, N is equal to 0. So here V by 2 and root of here M is equal to 1 and N is equal to 0. So here 1 by A whole square. Now that becomes V by 2A. So that means that is V by 2. This is 1 by 2 whole square. that is nothing but V by 4. That means this is 0.25 into V. So this cutoff frequency is for TE10 mode and TM10 mode. Next, third one, FC01. That means M is equal to 0, N is equal to 1. So FC01 means V by 2 root of M0 N1 then 1 by B whole square. So that means V by 2 B is equal to 1. So that is nothing but 0.5 V. So this is the cutoff frequency for TE01 mode and TM01 mode. Fourth one, FC11. So M is equal to 1, N is equal to 1. So V by 2 here, this is M is equal to 1, A value is 2, so 2 square plus, and then N is equal to 1, B value is 1, 1 square. So ultimately you get this one. This value, if you calculate, you get 0.55 V. Okay. We are calculating these frequencies in terms of velocity V, and if it is air field then it is C. If it is dielectric field then C by root mu or epsilon r. So this is the cutoff frequency for TE11 mode and TM11 mode. Now students, this mode does not exist, this also does not exist. So this for TM modes either M0 or N0, they doesn't exist. This one exists, this exists, this also exists, this also exists. Here I am using the symbol, this symbol means mode does not exist. Okay, this symbol means mode exist. Okay. Now here the modes which can exist are TE10, TE01, TE11, TM11. These modes exist actually wherever tick mark is there. We have studied TM00, TM1001. These modes doesn't exist, either M0, N0, they don't exist. And this here what is written? This I think ink came here. Ink TE00 mode, this does not exist. Okay. So among TE modes, the dominant mode having lowest cutoff frequency is TE10 mode for A greater than B. Among TM modes, the dominant mode is TM11 mode. But among all modes in the waveguide, the dominant mode is TE10 only. TE10 only. That is important. I will write 3 statements if you want. For A greater than B, in the rectangular waveguide, TE10 is the dominant mode among all TMN modes. Okay. So for A greater than B, in the rectangular waveguide, TM11 is the dominant mode among all TMMN modes. Next, for A greater than B, in rectangular waveguide, TE10 has least cutoff frequency, so TE10 is the dominant mode among all modes of rectangular waveguide. So, for A greater than B in rectangular waveguide, TE10 has least cutoff frequency. So, TE10 is the dominant mode among all modes of rectangular waveguide. You take TE modes, TM modes, all modes, then this is the dominant mode for A greater than B. If A less than B, here bigger one is A, wherever bigger number is there, for that 1 should be there, and for smaller value 0 should be there. If A less than B, then TE01 is the dominant mode, but it is standardized that in waveguides always A greater than B is taken actually. So, this point you have to remember, students, right? It has least cutoff frequency or otherwise highest cutoff wavelength. Now, let us find that value. Here you know that FC10 is equal to definition is V by 2 root 1 by A whole square 0 by B whole square. Now, that is equal to FC10 is equal to V by 2A is the formula. This is very important where for dielectric filled rectangular waveguide, V is equal to 1 by root mu epsilon, that is equal to C by root mu r epsilon r. Okay, right. Next, the same FC. Okay, I will write like this only. For air-filled waveguide, for air-filled rectangular waveguide, V becomes 1 by root mu naught epsilon naught, so that becomes C in this formula. Okay, right. Next, I told you V is equal to lambda into F, and V is equal to, if you take cutoff wavelength, then you have to take cutoff frequency. Now, here it is written like this: V is equal to, if you take lambda C for Mn mode, you have to take cutoff frequency for Mn mode. So, here lambda C for 10 mode here, that means that implies lambda C Mn is equal to V by Fc Mn. So, lambda C Mn is equal to here from this V by Fc10. So, that implies lambda C10 is equal to V divided by, what is Fc10 from this? V by 2A. Okay, if you want you can give the number. You give this as equation number 1, and you give this as this is the definition, equation number 2. So, you put equation 1 in 2, then you get lambda C10 is equal to V divided by Fc10 is V by 2A. That implies lambda C10 is 2A, students. This is important. Cutoff wavelength for 10 mode. So, every time in examination they give this only, because we send the energy in the rectangular waveguide through TE10 mode, dominant mode, because that has least cutoff frequency. You can send energy from lowest frequency onwards, you can send. Okay, right. Now, be careful. If A greater than B, then only this is valid. Then if B is bigger, then you get here FC01 you get, then V by 2B you get, then FC01 is 2B you get here. Right, students? Next point. Modes having same cutoff frequency are called degenerate modes. Degenerate modes. modes having same cutoff frequency are called degenerate mode, students, right? First point in that, if A not equal to B, then waveguide is rectangular cross section, waveguide is rectangular in cross section, rectangular in cross section. So for rectangular waveguide TEMN comma TMMN both have same cutoff frequencies, now students. So for rectangular waveguide, in rectangular waveguide लिखना सही है. In rectangular waveguide TEMN and TMMN have same cutoff frequencies, same cutoff frequencies. So they are degenerate modes, right? Next, if A is equal to B, then waveguide is square in cross section. That means that is called square waveguide. In square waveguide, TEMN, TENM, you can interchange them. TMMN, TMNM. Because if A is equal to B, dear students, then you can see here in this formula, if A is equal to B, here A is equal to B, then here A you put, here A you put. In that case, this is 2, this is 3, this is 3, this is 2. You can interchange, but you get same answer. So that's why, right? If A is equal to B, then waveguide is square in cross section. So in square waveguide, TEMN, you can interchange them NM, and for example it is 2, 3, then 3, 2 also will have same cutoff frequency. Modes have same cutoff frequency. So they are called degenerate modes. It is called foursome, मतलब चार है. Foursome means F O U R 4, चार. Foursome square degeneracy. That means square waveguide. Foursome means 4, square means square waveguide, degeneracy means degenerate modes, having same cutoff frequency. Foursome square degeneracy it is called, right? So this is also in note, okay?